In this video I'm going to explore how a peak model might be created for data such as these. I'm not going to try and fit the oxygen 1s. I'm going to focus on just the vanadium 2p, and this poses a problem, and the problem is more obvious when we create a background that we attempt to identify just the vanadium 2p signal. And the reason this is a problem is that the ratio of this vanadium 2p 3/2 peak compared to the vanadium 2p 1/2 peak is not in the ratio that we would expect if we choose a background of this form. It looks like it's working reasonably well in the sense that the background does not cut through the data significantly. This is a Shirley background, except for there's a small metallic peak here, and therefore there must be a small metallic peak over here, and it looks quite difficult to identify that second peak given a background of this form. Then if I were to choose to span the interval of photoemission from both the vanadium and the oxygen, we start to see something that perhaps makes a little bit more sense for the vanadium. The ratio of these two peaks, it certainly looks like it's going to be feasible to produce a 2:1 ratio that we need for vanadium. If we don't get that 2:1 ratio, we have to question any peak model. So we can't ignore physics. The physics suggests that for a doublet peak that's a p orbital, we ought to have a 2:1 ratio or thereabouts. And if we don't obtain that, then we know we've done something wrong. So this Shirley background looks like it's making it possible to have that ratio that's required. However, I will have to deal with the oxygen 1s. That is, I would have to add a peak model to allow for the signal interaction between the vanadium 2p and the oxygen. I really don't want to do that. I really don't want to have to understand the chemistry of this oxygen, because it's not just vanadium oxide, there's also carbon involved and carbon bonded to oxygen. So I would have to add peaks that I have not enough information to be certain of what I'm doing. The way that we could eliminate the oxygen 1s from the peak model might be to introduce another background, and I'm going to enter null, and what you will see over the span of this second interval, you see that the data now turns the color of the background. So what's actually happened here is this null background is returning the background to the data. So if I want to choose a different limit for this second background, so I moved up the background limit so it's encompassing both the oxygen and some of this background. Oh, we don't have to use the background, so I can move this over here, and the result of using this null background is that the background that will be included in the optimization will be the Shirley background up to this point, and then in fact there will be a 0 from that point on. And that might not be perfect, but it's a first start at producing a background for just the vanadium 2p signal, so I can now attempt to produce a peak model for vanadium only. So let's add a couple of peaks. I'll change the display mode so we can see these peaks, and if I say fit, I end up with a pair of peaks, and the ratio of these peaks looks like it is close to 2:1. So I've certainly improved the situation. If I want a very basic peak model for this vanadium oxide using synthetic line shapes and a Shirley background, I would have had to arbitrarily chosen this position if I were to rely on my eye to work out where the background ought to go. But because I can span both the oxygen and the vanadium using the Shirley background and then remove part of the signal, the oxygen 1s, just enter up here oxygen 1s so it's clear what's missing now, and I'll just set that to 0 because it has no part in this peak model. So this is just a way of removing peak structure that I don't want to deal with as part of my peak model. Now I do need to add further information to this peak model, in the sense that I haven't accounted for this, which is now more obvious, metallic form of the vanadium. But even without the metal phase, I can see that the oxide that I've worked out looks about right.